Okay, here's the third example of balancing an equation I'm going to show by setting up a table to help us out. And this is a combustion reaction. We know it's combustion because it reacts with oxygen. And balancing combustion reactions can be a little trickier. So there's a couple of tricks I'm going to show you in this to help you solve that. Just like before, though, I'm going to use the same exact strategy I've been using. So I'm going to set up a table underneath to keep track of how many of each element I have on this side and how many I have on this side. And remember, an equation is balanced when the number of each element on this side equals the number of each element on this side. So on my left-hand side, I have 2 carbons, 6 hydrogens, and 2 oxygens. On my right-hand side, I have 1 carbon, 2 hydrogens, and now here's the first place where it gets a little tricky. I have 2 oxygens from this, plus 1 more from this. That's 3 total. In my table, I need to put the total number of oxygen I have on the right-hand side, which is 3. All right, another trick to combustion reactions. You see how oxygen are in multiple different products? That's going to be kind of a pain to balance, so we're going to save that for last. I'm going to do every element but oxygen, and then I'll worry about oxygen. So let's start with, I'm just randomly going to pick carbon. I have 2 carbons on this side. Only 1 on this side, so I need to double the amount of carbon on this side. Put 2 in front of that, and now I'm going to update my table. I have 2 times 1 or 2 carbons. And now the total number of oxygen, 2 times 2 is 4 from this, plus 1 more from this. Don't forget about this one here. I've got 5 total oxygens now. Now let's move on to hydrogen. I have 6 hydrogens on this side, only 2 on this side, so 2 times what equals 6? Turns out that's 3. So I need to put a 3 in front of this, and I need to update my table again. 3 times 2, 6 hydrogens. And now oxygen. 3 times 1 is 3 oxygens, plus 2 times 2 is 4 oxygens. I need the total number of oxygen from both of these, and it turns out that it's 7. Again, there's 4 from this, plus 3 from this, so 7 total. All right, I've done carbon, I've done hydrogen, now I just have oxygen. 2 times what equals 7? That's kind of difficult. There isn't a whole number where that's the case. 3.5 times 2 equals 7, so that would balance. The problem is I don't like having decimals whenever I balance an equation. I would much rather have a whole number. Well, I can get a whole number if I double everything. The reason I know to double everything, 3.5 times 2 equals 7, so now I have a whole number there. But if I'm going to double this, I got to double everything else to keep it balanced. So 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. So overall now, I got to update my table and just check to make sure I've actually balanced this correctly. 2 times 2, 4 carbons on my left side. 2 times 6, 12 hydrogens on my left side. 7 times 2, 14 oxygens on my left side. Now my right-hand side. 4 times 1, 4 carbons. 6 times 2, 12 hydrogens. Now I got to keep track of oxygen. That's the most difficult one. 4 times 2, 8 from this, plus 6 times 1, 6 from this, so 8 plus 6 is 14. Looks like my carbon's balanced, my hydrogen's balanced, my oxygen's balanced. This was a pretty difficult one, but I was able to get it balanced. And the way I was able to get it balanced is by updating my table every single time I changed a coefficient at the very top of this. Don't forget to do that anytime you have to balance.